In this video we're going to look at mapping diagrams. A mapping diagram is a way of representing any mapping between one set of elements and another set of elements. Traditionally speaking, they look like this, where the green set is the first set of elements and the red set is the set of elements we get out from our mapping. So for example, if in our green set we had the elements -1, 0, 1 and 2, and our mapping was to double each of our inputs, then we would take the -1, we would double it, and we would get -2. We would take the 0, we would double it, and we get 0. We take the 1, we double it, we get 2, and we take the 2, we double it, and we get 4. This is a traditional mapping diagram, and there are a couple of words here that we need to introduce briefly. The green set, that's the set we start with, is called the domain. That's the input, the things that we can input into our mapping, and the things that we get out of our mapping, the output, is called the range of our mapping. So we have the domain is what we put in, the range is what we get out of our mapping. There are other ways we can write this. In particular, we can write it as a set of ordered pairs. So it's a set, so we have to use squiggly brackets, and each pair we have -1 goes to -2. Next pair is 0, 0. Next pair is 1, 2, and the final pair is 2, 4. Close our set. So that's another way we could write this mapping, is as a list of ordered pairs. We also notice for this mapping that every element in our domain goes to a unique element in our range. That is, they all go to different elements. That is not always the case, as we shall see in the next example. So in the next example, in our domain, we're going to have the same numbers, -1, 0, 1 and 2, and this time our mapping is going to be to square the numbers. -1 squared is 1, 0 squared is 0, 1 squared is 1 again, so we go up to there, and 2 squared is 4. Again, we could list the ordered pairs, and we would get -1, 1, 0, 0, 1, 1, and 2, 4. Now in this one we notice that both -1 and 1 go to the same output, the same element in the range, which is 1. So we need names to describe these mappings. Our first mapping, where they all go to something different, is called a 1-to-1 mapping. And the second one we've looked at, this one, is called a many-to-1 mapping, and that's because many elements from the domain can go to just one element in the range. Finally, we're going to look at one more example, which is a slightly different one again, and this time in our domain we have 9, 4 and 1, and our mapping is going to be the square root this time. So the square root of 9 could be 3, but it's also -3, because both those numbers square to make 9. For 4, it could be 2, or it could be minus 2, and for 1 it could be 1, or it could be minus 1. So for each of these input numbers in our domain, we have multiple output elements in our range, and this is called a one-to-many mapping. That is, one element in the domain can map to many different elements in the range. So these are mappings, but we've been looking at functions, and there is an important difference here. A function is a mapping where every element of the domain goes to one element in the range. That is, it could be like this: every element in the domain goes to a different element in the range, but importantly they only go to one element in the range. Or it could be a many-to-one, where every element in the domain goes to only one element in the range, but they might go to the same one as another element from the domain. But it cannot be one of these. Okay? This is not a function. A function cannot happen if you have one thing going to two different elements in the range. So a mapping to be a function, each element of the domain must map to exactly one element of the range. Okay? You could only get one output for any given input. That's what makes it a function. Now, to check this, we could check the ordered pairs, and we can only have one range value for each domain value, or we can look at the mapping diagram, and for any value in the domain, in the green circle, we can only have one arrow coming out of it to one thing in the range. Or we can look at the graphs. Sometimes we have a graph, and we can graph functions as well. So we might have this function here shown by this graph, and the way we check if a graph is a function or not is we do what's called the vertical line test. And the vertical line test means if we were to draw a vertical line at any point through the graph, it must only cross the function once. So this one is a function because no matter where we draw our vertical lines, it will only cross the function once. Here's a second example. So we draw our vertical lines, but once again, no matter where we draw our vertical line, it only crosses our graph once. So this is also a function. One final example, we have this one here. In this one, if we draw vertical lines, we immediately see a problem because each vertical line crosses the function twice in this case. So this is not a function because it fails the vertical line test. I will point out at this point that a vertical line might go through and not touch the graph at all. That is fine. The important thing for it to be a function is that it must not cross the graph more than once. So if it doesn't cross at all, it's okay, and if it crosses once, it's a function. But if it crosses more than once, then it's not a function.